Numbers in regions. We have met this Venn diagram before, so it pertains to the universal set 1 to 6 with the odd numbers and the prime numbers. And so the bounding rectangle contains the universal set of 1 to 6, the set of odds, the set of primes. 1 is odd but not prime. 2 is prime but not odd. 3 is both. 4 is neither. 5 is both. And 6 is neither. So we want to identify the number of elements in the set O. So if we look in the bounding ellipse for O, there are 3 elements. Then the number of elements in both, and finally the number of elements in this set here. So the number of elements in O, as we just counted, are 3. The number of elements in the intersection of O and P is 2. But for this last one, we may need to identify the set. So it's not O, the complement of O, in union with P. So I'm going to shade not O, so that's everything around the outside of O to start with. Then in a different colour, I'm going to shade P. Because this is a union, we want everything that appears in a shaded region, which is absolutely everything except this one here. Therefore, there are 5 elements. We have the relationship, the number of things in A union B is equal to the number of things in A plus the number of things in B, take away the number of things in the intersection. And we're going to apply that to a problem. In a group of 40 students, 22 study physics and 19 study chemistry. 5 students study neither subject. How many students do both physics and chemistry? So, we know that the universal set contains 40. We know that the number of things in the set P is 22. We know the number of things in the set C is 19. And we know the number of things that are in neither, so that's P dashed intersection C dashed is equal to 5. Now, one way we could go about doing this is to use a Venn diagram. It's a nice way of visualizing this formula. So I know that this is the universal set and that it contains 40. This is the set P, this is the set C. I know in total there needs to be 22 in here, and in total there needs to be 19 in here. I already know there are 5 students outside. So let's just call this X. Then because this entire ellipse needs to contain 22, there must be 22 minus x here. And this entire ellipse needs to contain 19, so there must be 19 minus x here. So 22 minus x plus 19 minus x plus 5 has to be equal to 40. If we add up all 4 regions, it must come to the total. So 22 add 19 is 41 and 5 is 46. Minus x plus x minus x is minus x. And that tells me that x is equal to 6. So we now know that this is 6. And therefore this would be 16, this will be 13. And if we add all of those together, all four numbers, it does give us 40. So let's come over and look at the formula. The number of things in A is 16 and 6, which is 22. The number of things in B is 19. And we've now found that this is 6. And the number of things in A union B, therefore, is 35. And we know that because there's 40 in total and there's 5 outside. So we could have done this without the Venn diagram, because as soon as we knew this piece of information combined with this piece of information, we would have known that the union must contain 35. So we could have used the formula. But it's nice to be able to do it both ways. It is worth remembering the four regions of a standard two-circle Venn diagram. So this region is A intersection not B. It's the part that's inside of A and not in B. This is A intersection B. That's the region that is both within A and within B. This is A dashed intersection B, so it's in B and not in A. And this is not A intersection not B. It's where that which is outside of A intersects with that which is outside of B.